Hey, it's Miss Miklos, and in today's lecture we are talking about hyperbolas. And once again, this is something we've learned before, but we're going to learn some new stuff. We're going to build on and talk about some different characteristics that we didn't really go into depth on last year. So first of all, the definition, a hyperbola is a set of all points, x, y, in a plane. The difference, this being the key term here, of whose distance is from two distinct points. The foci is a positive constant. So we can kind of see here. We have our hyperbola. Every single point on these two parts of the hyperbola is the same distance away from these two foci. So if we subtracted this distance and this distance, it would equal a constant. Okay, and that's how all of these values are found. Now, some other characteristics that we're going to talk about, we call these 2 points right here a vertex. So the plural vertex is vertices. So these are the 2 vertices. Okay, we have a center. We call these branches. We don't use that term a ton, but just so we know what they're called. And then we also have what we call the transverse axis. Okay, so in this case, this would be the transverse axis. Now, I want to kind of talk about some characteristics. How do I know that something is a hyperbola? So with a hyperbola, both x is squared and y is squared. That's what differentiates this from a parabola. And in a hyperbola, we have subtraction. So that's what makes this different from an ellipse or a circle. So it could be x squared minus y squared, or it could be y squared minus x squared. So looking at the standard form of an equation, you guys might notice that these are very, very similar to an ellipse. Okay, the important things for us to remember, and honestly, I don't really care if we know this terminology of a transverse axis. We can just kind of leave it there. The thing that's important for us to know is what direction should we graph. So when x is positive, we're going to graph right and left. When y is positive, we're going to graph up and down. And we will see that as we get into some examples here. The other important thing for us to know is how do we find the foci? Okay, in an ellipse, our equation was c squared equals a squared minus b squared. In a hyperbola, it is c squared equals a squared plus b squared. So that's how we are going to go ahead and find how far away the foci are from the center. Here are examples. If our center was at 0, 0, it would be x squared and y squared. And then here's just some quick pictures of what these look like. Okay, in this case, okay, notice x is positive, so we're graphing to the right and to the left. In this case, notice y is positive, so we are graphing up and we are graphing down. The other thing I want to point out here is that the foci are always inside our hyperbola. Okay, so it's kind of like what we saw in a parabola where we always moved inside the parabola to put the focus. Here it's that same idea. Okay, I'm moving inside whatever direction that is. Example number 1 tells us to graph the hyperbola and find its center, vertices, and foci. So, first thing we notice here, okay, obviously it tells me it's a hyperbola, but I can also tell that because we have subtraction. So, I need this, that's a really ugly need, okay, to be a 1. So, just like in an ellipse, we start by dividing so we can get a 1. So I get y squared over 4 minus x squared over 16 equals 1. Okay, so this is in the correct form. So the first thing that we're going to figure out is what is our center. Okay, we know our center comes from the parentheses. In this case, I don't have any, so my x is going to be 0 and my y is going to be 0. So my center is 0, 0. Okay, so I'm going to go ahead and put a point at 0, 0 on my graph. Now, the other thing I need to determine is how far out are we going? Okay, in the y direction, it looks like I need to go out the square root of 4, so I'm going to move 2 up and down. with this 16, I'm going to square root that, and that tells me that I'm going to move 4 right and left. So you guys may remember doing this last year, so I'm going to go up 2 and down 2. I'm going to go to the right 4 and to the left 4. And this was the fun shape where we get to draw the box. Okay, remember that this is dashed. The reason being is these are not solutions. The whole purpose of this box is to allow us to draw the diagonals, which are the asymptotes. Okay, so there are the asymptotes. So we need to determine at this point, what direction should we graph in? I notice here y squared is positive. So since y is positive, I need to graph it up and down. So what I'm going to look at here, notice I plotted 4 distinct points. One is up and one is down. Okay, so that is going to be my vertex. I know that my hyperbola is getting really close to the asymptotes, but it's not actually going to touch it. So this actually tells us where our vertices are. So I can go over here, and I'm going to write vertices are at 0, 2, and 0, negative 2. Okay, so the vertices, let me actually zoom out a little bit. There we go. The vertices are always going to be the direction that I graph. Okay, so if we had decided that we needed to graph it right and left, then my vertex would have been here and a vertex would have been there. So the final thing we need to do is figure out where are the foci. So I'm just going to write foci, and we said the equation we need to know here is c squared equals a squared plus b squared. So in this case, c squared equals a squared and b squared are these denominator values right here. So I have 4 plus 16, so c squared is 20, so c is the square root of 20, which is approximately 4.47. Okay, so that means that I need to move up 1, 2, 3, 4.47. Okay, and there is one focus. And then I need to move down from the center 1, 2, 3, 4.47, and that is the other focus. So if I go ahead now and write out those ordered pairs, okay, I'm going to say foci, 0, 4.47, 0, negative 4.47. So these are the values that they were looking for. Okay, I want to point out that just like in an ellipse, notice that all my x values in this case stayed the same. So we will always see either the x values stay the same or all the y values stay the same. And there we go. That is what our picture would look like. If for some reason we had foci that were not inside the hyperbola, that means that I made a mistake somehow. Okay, so let's do one that's a little bit tougher. So it says graph the hyperbola given by this giant equation. So the first thing that I see here is that we are going to need to complete this square. And when we're completing this square, I need to remember to factor out the leading coefficients. And the reason why I'm saying that here is because I notice that I have a leading coefficient on x squared. So I'm going to start by grouping my x terms together. And then I'm also going to group my y terms together. Okay, and I'm moving that 18 to the other side. I want to point out here that I kept it a plus in between. Okay, the reason being, I am going to factor out that negative, but I need to factor out the negative of everything. So that's why I want to wait and physically do it by hand. So I notice in that first group, I have a 9. When I take that out, I get x squared minus 4x. My second group here, I'm going to factor out a negative, so I have y squared plus 6y. At this point, we can figure out what to add here to create a perfect square trinomial. So I'm going to take negative 4, divide it by 2, and square it. So I get 4. Now to balance this on the other side, I need to remember it's like 9 times 4, which is 36. Okay, over here, I'm taking that 6, and I'm going to divide it by 2 and square it, so I'm adding 9. But I need to remember this is like a negative times 9, so I have to add a negative 9 to the other side. So when I factor this, I get 9 times x minus 2 squared minus y plus 3 squared equals 9. Now, in order to get this into the correct form, we know this 9 needs to become a 1. So I'm dividing everything by 9. And I get x minus 2 squared over 1 minus y plus 3 squared over 9 is equal to 1. So now we're ready to find our characteristics. So remember, we need to find what is the center, what are the vertices, and what are the foci. So altogether, we're finding 5 different ordered pairs. This time, our center is going to be 2, negative 3, because I'm taking the opposite of those values. I know 2 goes as the x-coordinate because x is in that parenthesis with it. So I have 2, negative 3. Now, off to the side here, I know in the x direction, I'm going to move plus or minus 1. In the y direction, I'm going to move plus or minus 3 because I'm taking the square roots of those values. So over here, okay, I want to go ahead and graph. Let me try and straighten that out a little bit. So we said 2, negative 3. And then I need to go 1 to the right, 1 to the left, and 3 up and 3 down. Okay, so I'm going to go ahead and draw out my rectangle. Okay, that's kind of rough, but we can see where the asymptotes are. Now, based on this equation, I see that x is positive. So I'm going to graph to the right and to the left. So I'm going to find these vertices that I already plotted. And I'm going to graph to the right. And I'm going to graph to the left. Now I can see my vertices are at 1, negative 3, and at 3, negative 3. Okay, so I'm going to write 1, negative 3, and 3, negative 3. Once again, I always think it's easier to do when we're looking at the graph. I think graphing makes things way easier. Okay, final thing, we need to find the foci. So I'm doing c squared equals a squared plus b squared. So c squared equals 1 plus 9. So c is the square root of 10, which ends up being 3.16. So I'm moving to the right 1, 2, 3.16. And to the left, 1, 2, 3.16. Okay, so notice I'm moving that far away from our center. So what that means for us, okay, this ordered pair here is going to be at 1, 2, 3, 4, 5.16, negative 3. And then, if I moved here, it would be at negative 1.16, negative 3. Okay, so once again, this is like as tough as it gets, but it just takes practice in making sure we memorize how to find all these characteristics. The next 2 examples we're going to do are going to be the opposite, where we are given information and we need to come up with an equation. Number 3 tells us what the vertices and the foci are. So our motto the other day was, when in doubt, sketch it out or draw it out. So I'm going to start by graphing 0, 2, and 0, negative 2. Now the fact that my vertices are up and down tells me that my parabola has to go up and down. Okay, the other thing that I can see is my foci are at 0, 4, and 0, negative 4. So the first thing I'm going to do, Since it's up and down, y has to be a positive value. I can also see that the center has to be 0, 0 because the center is the same distance away from the vertices, or we can think of it as being the same distance away from the foci. So I'm going to start by saying y minus k squared over a squared, and honestly I don't care if you wrote a or b there, minus x minus h squared over b squared equals 1. And we already said that this should be y squared and x squared because our center is at 0, 0. Now the easy one for us to figure out is the y, because looking at this from the center, I can see that I'm moving 2 away to the vertex. Now in all the other problems, we took the denominator and we square rooted it, and that told us how far out to go to plot those points. So this time I'm going to have to take 2 and square it, which gives me 4. Now the final piece of information is that other denominator. So I'm going to use the fact that c squared equals a squared plus b squared. I can see that the focus is 4 away from the center. So I'm going to say 4 squared equals 4 plus b squared. So 16 equals 4 plus b squared. So 12 is our b squared term. So my equation here is y squared over 4 minus x squared over 12 equals 1. So key things we need to find here, we needed to find the center to come up with this y squared and x squared. We needed to go ahead and also realize that y squared should be positive because it's going up and down. And then we had to find these two denominators. The one denominator is easy to find because of the vertices. The second one we had to do a little bit more work and use the idea of how far away are the foci from the center to help us find the other denominator. And our final example once again gives us foci and vertices. So I'm going to go ahead and sketch this out. So our foci are at -1, 2. So I'm writing an F, 2, 3, 4, 5. And our other focus is at 5, 2. Now some things that I noticed right here. I can actually determine what the center is based on those two. We know that the center has to be the midpoint. So to me, the midpoint looks like it would be at 2, 2. Now the other information, give it to me. My vertices are at 0, 2, and 4, 2. So that tells me that my hyperbola is opening right and left. Notice that 2, 2 is also the midpoint of these vertices. So some things I know this time my x needs to be positive, and it's going to be x minus 2 squared over something minus y minus 2 squared over something equals 1. I can see that I'm moving 2 in the x direction to get to those vertices, so my x denominator is going to be 4. The other thing that we know is that the foci are 1, 2, 3 away. So I'm going to say c squared equals a squared plus b squared. So 3 squared equals 4 plus b squared. So 9 is 4 plus b squared. So 5 has to be our b squared term. So that would be our equation. Now, quite honestly, writing the equation doesn't get more difficult than this. It's just super repetitive. We need to keep practicing. And I think the most difficult part about hyperbolas is remembering all these characteristics because they're really similar to an ellipse. So I would definitely advise that you guys spend some time memorizing how to do these all separately, because I think that's the toughest part about this test, is that it's not just all hyperbolas or all ellipses. Okay, first of all, we need to be able to tell, is it a circle, is it a parabola, hyperbola, ellipse? Secondly, we need to know, how do we find all those characteristics? So keep studying, and please come and see me if you guys have any questions.